Here's a sample problem. Calculate the standard cell potential required for the electrolysis of zinc chloride. If it helps, sketch out how the cell would look. What would you suggest the electrodes be made of? The graphite electrodes mean we don't have to worry about the electrodes reacting. We're being asked, what should the minimum voltage of the battery be? Well, we start by deciding on the half reactions to write out. What species are present? Zinc ions, chloride, and water. It might not play a part in the calculations, but list it in case. By looking at our data book, we can see that the zinc ion is the strongest oxidizing agent. So we show the electrical potential for the reduction of zinc. The chlorine ion is a reducing agent, but an even stronger reducing agent is water. We then apply our equation to calculate the cell's standard electrical potential. The standard cell potential required for the electrolysis of zinc chloride solution is 1.99 volts. Secondary cells, it seems, are merely discharged primary cells with an electron pump added to make the reaction go the other way. Once the reverse reaction has completed, remove the electron pump and you have a voltaic cell again, ready to be discharged. It's not as easy as adding a power source to a discharged dry cell to make it work again. The chemical composition has to be specific so that upon recharging, no side reactions occur, causing the battery to damage or even explode. The most common rechargeable battery is the car battery. Most cars are fitted with a lead-acid battery. When you start your car, the battery discharges as a voltaic cell. However, the engine movements provide energy to drive the alternator, which serves to recharge the battery. All secondary batteries operate as both voltaic and electrolytic cells. As the diagram shows, lead-acid batteries are made up of a series of cells with lead anode and a lead-2 oxide cathode with a sulfuric acid electrolyte. Your textbook details the reactions that occur at each electrode. The nickel-cadmium rechargeable battery is made up of 3 cells in series to produce 1.4 volts. It is widely useful to offset the cost of continually replacing dry cells. However, cadmium must be disposed of properly, and once that battery cannot be recharged sufficiently anymore, many people do not recycle their batteries and so they end up in landfills. The toxic cadmium seeps into the groundwater and then into the food chain. Even low levels of cadmium exposure over the long term can cause us some serious health problems.